Welcome back to the sixth and final video for our certification exam rapid training for the AZ204 Azure Developer Exam. Our sixth and final video is going to cover our last section, our fifth section of the exam, which is connect to and consume Azure services and third-party services. So again, this is a large portion of the exam, 25 to 30% of the exam. And I'm going to apologize. I'm going to be moving rapidly through various slides here because you're going to see a lot of content in terms of the topics here. So there's 25 to 30% of the exam with a lot of different services. So we're looking at Azure App Service Logic Apps, so our serverless workflow. We're looking at API management, event-based solutions. So several services here in terms of event grid, notification hubs, and event hub, and developing message-based solutions in terms of service bus and storage queues. So understanding the difference between a service bus queue and a storage queue would be vital here. So starting out really quick, our app service logic apps, again, this is an automation workflow. We're looking at workflow design. So we may have various steps that we're going to be walking through. Logic apps, this is the old BizTalk team, actually, the BizTalk APIs are available to advanced integration solutions. So you can actually integrate with other third-party systems. It is a JSON-based workflow definition. They can be deployed using our ARM templates. So again, there's out-of-the-box support. There's tons of different connectors with on-prem integrations, SAP integrations, all kinds of third-party integrations. Highly advise that you look at the various connectors here. So our components include workflows, triggers, actions, and connectors. The key here is understanding how these components interact with one another. Highly advise you go create a logic app. You'll see the various triggers and actions and how they can connect. The key to the workflow is understanding a workflow can actually be nested. So you could actually take one workflow and invoke another workflow with multiple actions and connect to various systems. That may be hosted third party, on-prem, again, in a different cloud or even in Azure. So understanding that this is a workflow, we're gonna have various actions that we're gonna perform. We're gonna connect to various systems and do different things. So the key to the exam here is with logic apps, we're going to actually be creating custom connectors. So we want to understand the connector components. So you could actually code a custom connector that's composed of actions and various triggers. And understand there's two different types of triggers. You can actually have a push or a polling type trigger and understand the usages of those. So moving on to API management, we really want to focus in on creating a PIM, so setting up a PIM, configuring auth for the APIs, and policies. Policies is a big aspect of API management, understanding how to apply those policies. So API management, we're going to host our API endpoints and actually have a developer portal associated with those API endpoints. So we really want to understand APIM in terms of the various terminology that we have. So our backend API, our front-end API, what a product is, and what an operation is, and how that applies to our various hosted APIs. Also, how do we version our APIs? What does that mean? What does a revision mean? And what is the developer portal? And can we customize that developer portal? What does that developer portal actually provide in terms of our APIs? So understanding products, again, that they contain one or more APIs in a package. They can be open or protected. So you may have a particular API that you want to monetize. We may want to create a product out of the monetized API, where we have maybe internal APIs or other APIs that we have exposed that we don't want to monetize. Those could be separate products, essentially. Policies, like I mentioned, big area for APIM. or API management. Policies, they're a powerful capability that allow the publisher to change the behavior of the API through configuration. So policies, they're a collection of statements that are executed sequentially on the request or response of a particular API. Popular statements include format conversion, say from XML to JSON, and call rate limiting to restrict the amount of calls from a particular developer. But you have many more policies. You can write custom policies. So know that policies really drive API management behavior. And understanding policy scope. So when we apply a policy, if we want a global policy, we would apply that at the base, and understanding what inbound versus outbound policies mean to API management. The various policy scopes in terms of the various components, like we mentioned, the back end, the front end API. What does that mean if we put our policy on inbound versus outbound? Again, that's the request response. So if we wanted to filter, incoming requests, we would apply an inbound policy, for example. But again, if we wanted to invoke them for the entire API, regardless, we could apply them at the base. So Event Grid, we really want to focus in on our various use cases for Event Grid. So Event Grid has sources and handlers. So an event source is where the event is going to happen. Several Azure services automatically are configured to send events. You can also create custom apps that send events. So you can use Event Grid, again, as your event source consumer. And then you have handlers. Those handlers is where the event is sent. So the handler takes some further action to process that particular event. So again, several Azure services are automatically configured to handle events, and you could use webhooks for handling events. And the webhook doesn't need to be hosted in Azure to handle those events. And Event Grid only supports secure webhook endpoints, so do know that. So Event Grid, we want to understand the various concepts inside of Event Grid, what an event is, what a topic is, what an event handler is. Again, understanding that each event is limited in size, in size of data. So we're looking at very small sizes, 64 kilobytes of information in terms of an event. Event hubs, they're scalable event processing service. This is for massive amounts of telemetry or large amounts of information for ingestion and processing. So think of massive amounts of events. So you had a ton of IoT devices deployed to thousands upon thousands of areas that are sending signal events. You'd use event hubs. There actually is IoT event hubs to ingest that information. So it's a time retention durable buffer for telemetry ingress, similar to a distributed log. So you can actually use Event Hubs capture. You really want to be familiar with this process. Event Hubs capture enables you to specify your own blob storage account or data lake storage account, which you can actually store and capture the data. So understand that concept. Event Hubs capture is a feature. And the data is actually written in an Apache Avro format. It's a compact, fast binary format. It's typically used in the Hadoop ecosystem, Azure Stream Analytics, and Azure Data Factory. So understand the data, understand the usage of event hubs, and that it's for massive ingestion of information. Notification hubs, think mobile notifications. This is for push notification engines. You can templatize these, you can send these out, and they interface with a lot of different push notification services, such as Apple's push notification service, Windows push notification service, or Android with the Firebase cloud messaging push notification service as well. So it's interaction and abstracting you from the push notification services and being able to send and receive from client devices. So step one, the client app is deciding it wants to receive a notification. It's going to contact that push notification service. The client app, for number two, stores this handle for the app in the back end. And then number 3, we're actually going to send a push notification, and the app backend contacts the push notification service by using that particular handle. And number 4, the push notification forwards the notification to the particular device. Know that you can group notifications. So you can see here, there's actually device registration included in this service. So we can actually know the particular device or tag particular users as well. So we can actually target particular devices, particular users. So you can route them accordingly. Azure Service Bus. This is for enterprise level integrations. You have 3 communication mechanisms. You should know queues is a big or popular area, but understand topics and relays. So understand the differences between a queue, a topic, and a relay. Azure Service Bus queues are first in, first out. So you can actually configure them to be, again, they're first in, first out messaging. And that's a big differentiator as we talk about Azure storage queues, which are not first in, first out messaging. But it's a way to decouple applications. You really want to understand the types of data that you can store in here. Message is essentially binary. It can contain JSON, XML, or just simple text in the sizing of those messages as we communicate. So again, a queue, messages are sent to and from. This is a first in, first out delivery. So we need to have that understanding. So it's understanding queues and an immediate, intermediate, essentially, message producer and consumer. Topics and subscriptions, they are processed a lot differently than queues. So understand the implementation of topics and subscriptions in implementing a pub-sub model, and how we interact and create messages for distribution in a topic or subscription. So comparing the cloud messaging options, you really need to understand, again, the difference between the various services in terms of event grid, event hubs, service bus, and queue storage. Here's some of the various advantages and weaknesses across those and the different types. So really understanding, again, first in, first out. If I would ask you, I need a queue that's first in, first out, no duplicates, we would look at service bus. We wouldn't look at event grid, or we wouldn't look at queue storage as an example. Speaking of Azure Queue Storage, it's a service for storing messages in an Azure storage account. So you can access this with HTTP or HTTPS. Millions of messages can be stored here, but again, this is not first in, first out. The single queue message can be up to 64 kilobytes. So very similar to what we saw with our events and event grid. These are very small messages, but it can contain millions of these messages up to a total capacity limit of the storage account itself. So the components of a Azure storage account queue, you have the URL format. You'll notice here the storage account itself, the queue, and the message. As I mentioned, the message can only be 64 kilobytes. The maximum time a message can remain is 7 days. So you have 7 days to interact with that particular message. So a quick practice question. So we're looking again. I talked about Azure Service Bus as being a first in, first out. You notice here the orders must be processed in order, which would be first in, first out. Duplicate orders should not be processed, so no duplicates. And again, that's Azure Service Bus for this particular queue. And here's our last practice question. So again, we talked earlier about large ingestion. So this is their event hub. It's a big data streaming. We're processing millions of events and pulling those in. So I appreciate it. Hopefully you've learned a little bit. Please use the deck to continue your learning. The Microsoft Learn area, please pull the deck down. We have added a few resources, and your call to action is, my call to action to you is go take the exam, please. And again, appreciate it and provide feedback.